Assalamualaikum and hi. My name is Nurul Hidayati Rahma binti Mama Hashim. Matric number B0319103880. For our assignment 2, we decide to do binary search in the divide and conquer algorithm. Binary search is a searching technique that only can be applied only to a sorted list of items. It works by comparing the search item with the middle element. It will stop the search if the item is found, else it will divide the array into two subarrays and continues the searching. To find the middle element in the array, we use this formula, which is first index plus last index divided by 2. Worst complexity is big O of log 2n, and best complexity is big O of 1. This picture given a sorted array and it will search a given element in array. For example, in case 1, it will search for 20 in the array. So firstly, we will find the middle element by using the formula earlier, which is 0 plus 8 divided by 2, we get 4. So our middle element in this array is 15. And then it will compare 20 with 15. If the comparison match, it will stop the search, else it will divide the array into two subarrays. For further explanation about how binary search works, it will explain in this next slide. That's all from me. Thank you.
Assalamualaikum and hi, my name is Hamizah Binti Yusni with metric number B0319100035. I will present about picture diagram of binary search. So before we start, I would like to explain how binary search works in general. So step 1, the data in the array will be divided into two parts, which are part 1 and part 2. So for the division, we will get the middle value. Next, step 2, the middle value will be tested to determine whether the target data is in the first half, which is left part, or second half, which is right part of the list. So, if target data is less than the middle element, searching will be done on the first half. But if target data is larger than the middle element, searching will be done on the second half. And then step 3, it will continue searching. It will stop when the start index value larger than end index value, so that it will determine whether the target data is found or not in the array. So this is the example of sorted list with size 7. So let's start with the picture diagram of binary search. First thing first, it will determine the start and end value and the target data. In this example, our target data is 79. So after that, the array will be divided into 2, so that we will get the middle value. Since we already got the middle value by using the formula, we can see here that it will get 24 as the current middle element. So middle element will be compared with target data. Since our target data just now is 79, 79 is larger than 24. If larger, start value will be updated, which means searching will be done on second half, which is right part. If in other case the target data is smaller than the middle element, then end value will be updated, which means searching will be done on first half, which is the left part. So for our case here, start value will be updated, middle plus 1, and searching will be done on second half. So start value updated to index 4 and end value remain the same, index 6. Since start value change, middle value will also change. So the new middle value is on index 5, which is 45. So it will be compared with target data 79, So 79 larger than 45. Since it is larger, same as previously, start value will be updated middle plus 1 and searching will be done on second half. So start value updated to index 6 and end value remain the same, index 6. Since start value change, middle value will also change, which is right now index 6 with value 79. So it will be compared with target data 79. Since it is equal, target data is found at the index of middle value, which is 6. So this is searching that found on second half. Next, example for searching found on first half. Our target data is 3. The process is same until this part. So since target data is 3, in this case, the target data is smaller than the middle element. 3 is less than 24. Since it is smaller, end value will be updated, middle minus 1, and searching will be done on first half, which is left part. So end value updated to index 2, and start value will remain the same, index 0. Since end value change, middle value will also change, which is on index 1 with value 8. So it will compare with the target data 3. 3 is less than 8. Since it is smaller, same as previously, end value will be updated, middle minus 1, and searching will be done on first half. So end value updated to an index 0, and start value will remain the same, index 0. Since end value change, middle value will also change, which is on index 0 with value 3. So it will be compared with target data 3. Since it is equal, target data is found at index of middle value, which is 0. So this is searching that found on first half. Last example, for searching that is not found in the array. Our target data is 2. The process is the same until this part. So for this case, target data 2 is smaller than middle element 3, which is 2 less than 3. Since it is smaller, end value will be updated, middle minus 1, and will become negative 1, and start will remain 0. Since the searching will only continue looping if start less than or equal to n, in this situation, start is larger than n, which 0 larger than negative 1. So, looping will stop and target data is not found in the array. That's all for picture diagram. To see the binary search flow in coding, my friend Amira will continue to show and explain the coding of binary search. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farzana Amira binti Adnan, B031910024.
Okay, so now I will explain to you the algorithm of binary search in C++. So let's open the Visual Studio.
Here we go. So right now I will type and run the whole C++ coding for binary search. Let's have the teaching. Right, return to do the binary search function first. So function here. Okay, so here we will have our array, the lower, the highest, and that we want to search. So here we will type the condition
the highest if the highest to lowest. If the highest is bigger or equals to lowest, we must to find middle. So how? This is the way to find the middle. So the lowest minus highest divided by 2. After we find the middle, we need to add more condition. How if the middle that we found is the number that we want to find? We need the condition if array of middle is equals to x. Okay, this is when the middle is the number that we want to find. Okay, we need to return the middle. Okay, so we need the logical thinking to do the correct condition. Okay, I add this. If array middle is greater than x the number that we want to find, we need to return the binary search for array lowest and middle minus 1 and x. Alright. Okay, what is happening on line 17? As you can see here, the lowest is remain the same. Okay, the lowest remain the same, but the highest is different now. This is the highest, but now the new highest is middle minus 1. It will find the x between the lowest index number and the one index before the middle index. Okay, since we only use the if statement, so we just return binary search array mid minus highest and x. What is happening here? Okay, in line 19, it will return if it is if x is not equals to middle, and if x is not greater than x, it will return the binary search. It will go here. The highest remains same, but the lowest. So the new lowest is middle plus 1. Continue with return negative 1. Alright. Okay. Now we continue with the main function. We need our array. Okay, I just add my own set of array. Here you can see this is ascending order. Continue. So now we need to set up the x, which is the one that we want to search. So I put it as 27 because that is my birthday. So yeah. Okay, and equals to. We are actually dividing the array into two parts. Alright. Okay, so now in this line 31, it is actually go to the binary search to see whether the x is exist or not in our set of array. If the result is negative 1, means that the x, the number that we want to search, is not exist in our set of array. Okay, so we need to see the element of x is not in the set of array. Yes, else the element of x is at the array number result. Yeah. Alright, here we go. The element of 27 is at the array number 5. Is it correct? If we found this 27 at Index number 5. Yes, correct. So why don't we test with the number that do not exist in our set of arrays? So let's go. I think change it to 22. Run it. The element of 22 is not in the set of arrays, so we did it. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Aida Shafati Binti Abdullah. My metric number is B0319103004. So I will be presenting about complexity of binary search. In each iteration or in each recursive call, the search gets reduced to half of the array. So for n elements in the array, there are log base to n iteration or recursive calls. These are time complexity for binary search, worst case O log base to n, and best case O1. So here some analysis of time complexity. For this example, there have 3 iterations. So for iteration 1, the array have given. From the array, we select the middle element and the target is 23. Select the middle element 16. Since 23 is greater than 16, divide the array into 2 halves and consider the subarray of the element 16. Discard all elements on the left including middle element. Subarray of the 16 will be taken into next iteration. For iteration 2, array is 23, 38, 56, 72 and 91. Select the middle element 56. Since 23 is smaller than 56, divide array into 2 halves and consider the subarray before element 56. Discard all elements on the right including middle element. Now, subarray with the elements before 56 will be taken into next iteration. So for iteration 3, it have 2 array 23 and 38. Select the middle element 23. Since 23 is the middle element, so iteration will stop. So to calculate the time complexity, let's say iteration in binary search terminate after k iterations. In above example, it terminates after 3 iterations. So here, k equals to 3. At each iterations, the array is divided by half. So let's say the length of array at any iteration is n. First iteration, length of array is n. Second iteration, length of array equals to n by 2. Third iteration, length of array is n divided by 2 square, which it can be n divided by 4. K iteration, length of array equals to n divided by 2 power of k. After k divisions, the length of array will be 1. So k iteration, length of array equals to n divided by 2 power of k equals to 1. N equals to 2 power of k. To applying log function on both sides, log base to n equals to log base to 2 power of k. Then log base to n equals to k log base to 2. So the answer will get k equals to log base to n. To convert it to bit notation, it will be O log base to n. That's all from me. Thank you.
Assalamualaikum and hi everyone. I am Shakira Nurfatiha Binti Zazali with metric number B0319100082. I will be presenting the suggestion of better algorithm than binary search. I choose interpolation search. Okay, this algorithm is an alternative to binary search that utilizes information about the underlying distribution of data to be searched. So that we can say that this algorithm works better than binary search for a sorted and uniformly distributed array. Interpolation is a method of constructing new data points within the range of discrete set of known data points in a sorted array. The concept of this algorithm is similar to how we search for words in a dictionary. We can see binary search always selects the middle value of the remaining space, remaining search space. It discards half of the values based on the comparison between the value found at the estimated position and the value to be searched, while for interpolation search, it finds an item near to one being searched for, and then linear search is used to find the exact item. We can also compare these two algorithms based on the time complexity. We can see that average case for running time for binary search is big O log n, and the average case running time for interpolation search is big O log n. In the hierarchy of big O notation, log n is at the higher position than log n, so that's mean that the big O log n faster than big O log n, so that we can conclude that interpolation search faster than binary search and it works better. That's all from me. Thank you.
Alright, that's all from us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.